Thank you very much, everybody. I'd like to start by thanking the Science Festival for inviting myself and my colleagues here from the Northern Ireland Science Festival. We will be having our own Science Festival next month in February. I would also like to thank the British Council for paying for me to come here and to tell you about a very exciting development in astronomy, a new type of object that we have only discovered in the past 2 or 3 years, where we have found near our planet objects from other stars. So I think I must start by giving you some background that you may already know or you may have learned in school. This is our solar system. It's a diagram where the planets and the sun are to scale, but the distances between the planets and the sun is much larger in reality. And we start with the sun on the left. Above we can see the major planets, Mercury, Venus, Earth, ourselves, Mars, and then the giant planets, Jupiter, Saturn, Uranus, and Neptune. Below, we have the 5 dwarf planets, smaller objects that aren't quite the same size as planets, but are still interesting worlds in their own right. We have sent spacecraft to 2 of them, Ceres and Pluto. Now, if that was all there was in our solar system, orbiting our sun, it would be a very simple picture for astronomers. But it is more complicated than that, because also going around our sun are hundreds of thousands, in fact millions, of smaller bodies. And depending on what they are made of, we give them different names. If we have something that is made of rock, we call it an asteroid. If it is made of ice, we call it a comet. Now, there we go. Asteroids, when we see them through our telescopes, appear as simple dots of light. We see them by the sunlight they reflect from their surfaces, and generally they are far too small for us to make out or see any details. Comets have ice in them, and when they come close to the sun, that ice melts and produces atmospheres and the tail of a comet. So normally we can tell the difference between a comet and an asteroid. We see them in different places in the solar system today, but when the solar system first formed, it was a very, very dynamic environment. Whole planets moved around to produce the solar system we see today, to produce the asteroid belt between the planets Mars and Jupiter, to produce the belt of comets we see beyond the planet Neptune. And in particular, by moving objects around, we see the remains of that process today, 4.5 billion years after our planetary system formed. During that process, it was very wasteful. The solar system has lost more than 100 million comets in its life. And they will never come back. All those comets are out there somewhere. Maybe they're near these objects. This is a recent image of solar systems being created around other stars, captured by a radio telescope in Chile. And around each of these stars we can see these disks of material being sculpted by the planets forming in them, they too will be losing many, many objects out beyond their gravitational reach into space. And where do these objects go? They go out here. This is our galaxy, the Milky Way. It contains 100,000 million stars. And if only a fraction of those stars lose these rocky asteroids and icy comets, then our galaxy must be full of those objects, moving between the stars, all too faint for us to see. But occasionally, sometimes perhaps, one would come close to our sun. And that is what we have been looking for over 400 years of scanning the skies with our telescopes. And that's what we were doing just over 3 years ago with this telescope. This is the Pan-STARRS telescope on top of one of the mountains in Hawaii. It is a telescope designed to scan the skies looking for new asteroids and new comets. And on the 19th of October 2017, so under 3 years ago, it's detected a faint streak of light moving in front of the stars and galaxies. It was spotted by a young American astronomer, Rob Work. He immediately realized this could be something special. But he found that image after the sun had risen, when it was no longer nighttime at the telescope. But when it is daytime in Hawaii, it is nighttime here in Europe. So he called his friend, Marco Michelli, who is operating a telescope for the European Space Agency here in Europe. And Marco found the object again. And they realized very quickly there was something special about it. This diagram shows how objects move about the sun. When an object is in orbit about the sun, it's known that they move not in circles, but in ellipses. If you like, squashed circles. And the Earth and the other planets and all the asteroids and comets that belong to our solar system move in these elliptical orbits. However, if an object is moving too fast to be captured by the gravity of the sun, then it will move in a very much more open curve, like so. And so, for the days after the discovery, we tracked this moving dot of light as it moved against the background stars to try and determine its trajectory. Now, this is a complicated process. To do this accurately can sometimes take many weeks, but for this object, we managed to do it in a few days. And this was the path of the object. Here we see the sun in the center of our solar system. Here are the planets Mercury, Venus, Earth, Mars, and then a big gap before we get to Jupiter. And here we see this object coming down from above the solar system, swinging around, being swung around by the gravity of the sun before it heads out again. And this showed us this was not of our solar system. After 400 years of using telescopes, we had discovered a visitor from somewhere else in our galaxy. Now, when you have a visitor to your house, it is polite to know their name. The astronomers discovered this object using a telescope in Hawaii. So they gave it an Hawaiian name. And because it is such an important name, all of us here need to know this name too. So the name the astronomers gave it is Oumuamua. Oumuamua. So repeat after me. Yes? Including you, Mr. Translator. O-mu-a-mu-a. Excellent. Again. O-mu-a-mu-a. Cool. Well done, everyone. So, in Hawaiian, that means a messenger from afar arriving first. The first object we have seen near our planet from somewhere else in the galaxy. That is a difficult name. Well done. It could have been much worse. This is the state fish of Hawaii. Anyone? Yes, very good. The homo homo nuku nuku apua'a. Okay. So, we have Oumuamua visiting us. Where did it come from? We can track the path back into the sky. And we see that it came from somewhere near the bright star, Vega. But not exactly from Vega, one of the brightest stars in our sky. It came from somewhere else. In fact, one of the first studies trying to track back its home, where it came from, were done here in Poland, at Poznań in Warsaw. And immediately it became obvious to them and other scientists that there was no star in our catalogues lying along its path. So we don't know where this object came from. But the likelihood is that when we look at our pictures of this dot of light, we see the sunlight reflecting from its surface. The last time it was that bright was in its home solar system, somewhere else out there in our galaxy. It's only a dot of light. That's all it ever appeared as in our telescopes. But we can still understand more about the object because astronomers are very good at studying dots of light. The first big study was performed by a team led by Karen Meach at the University of Hawaii, where Oumuamua was discovered. They studied how the brightness of Oumuamua changed with time. And in this graph, we can see that if this is brightness and this is time in hours, it is getting brighter and fainter, brighter and fainter, brighter and fainter. And that is because it is reflecting the sun, the light from the sun. And as it turns, it reflects less light and more light, less light and more light. And so that tells us how fast it is spinning. And it was spinning just over once every 7 hours, 20 minutes. But the most amazing thing about this was not how fast it was spinning three times faster than the Earth. It was the range of brightness. To change brightness that much, it must be very elongated, even more elongated than this laser pointer. What could it be? The theories on the internet were incredible. It could be a spaceship. It could be the universe's largest Polish sausage, which I am a fan of. But we think it was natural. We think this object, however it was formed, is this long, elongated shape. As more astronomers studied the data that they gathered on the object, they realized it was not even spinning simply, but it was changing how it spun as it passed by the Earth. Now, this is not unusual. We see this happening with other asteroids and other comets. But just to see this happening in our first interstellar visitor from another star was quite intriguing. We used all the telescopes that we could in the 1 week that we had to observe it before it got too faint. Here are two of the telescopes I used. The left-hand one is in the Canary Islands. It is a medium-sized telescope. I am the medium-sized astronomer standing underneath it. On the right, we have the very large telescope in Chile, and again, I am standing underneath it for scale. We used the world's largest telescopes, and there what we could do is split the light up into its component colors, and not just the colors that we can see by eye from blue to red, but extending further into the infrared. And what we saw was that the object Oumuamua reflected more sunlight as you went from normal light into infrared light. And that's something we see again with objects in our solar system. And finally, we only ever saw the object as a dot of light. But we know that when we study comets in our solar system, icy objects, there's an extra effect that we can look for, because the sun hits the comet, heats the ice, and the ice changes to gas and expands this way. So the gas and the small bits of rock and dust flow out towards the sun. But because of the laws of physics, that means the comet is very slightly pushed in the other direction. And indeed, after studying the motion of Oumuamua, it was seen that it exhibited the same effect, which tells us that even though we did not detect it with our telescopes, Oumuamua was outgassing very slightly and losing material as it passed by our star and our planet. Now, as I said, we only had about 1 week of time to study Oumuamua before it became too faint for most of our telescopes. But the data we gathered is so important that we knew we would be working for years on understanding it. So the following year, we put together a team of astronomers. to get together from all over the world to meet in Switzerland to try to understand and come up with some clear picture of what Oumuamua was. We met first of all in late 2018, and then we planned to meet again the following year in 2019. Because remember, it had taken us 400 years to discover the first visitor from another star. We would have a long time before the next one arrived. We were wrong. At the end of August last year, an amateur astronomer, an astronomer not paid to do science, but does it for their love of science, Gennady Borisov in the Ukraine, was scanning the skies with his impressive homemade telescope. And he found, when taking images of the sky low down near the sun, a moving, fuzzy dot of light. The fuzziness shows that it was a comet coming near the sun, ejecting gas, ejecting dust. But when astronomers put Gennady's measurements of its position in the sky together with many other measurements gathered over the following 2 weeks, it became clear that this was the second interstellar object, the second visitor from another star. Here is its path, again, through our solar system. The sun is in the center. Here we have the planets Mercury, Venus, Earth, and Mars. Here is the path of comet Borisov. This was where it was when it was discovered. And again, it has come in from above the solar system. The sun's gravity has bent its trajectory, and at the moment it is departing below our solar system. But the difference here is that we can see it in more detail because it is ejecting material, having been warmed by the sun. Unlike Oumuamua, comet Borisov is ejecting material into space. This is our closest or best image of the comet from the Hubble Space Telescope that was obtained just last month. We can see that somewhere in here, we cannot make it out clearly, is the nucleus of ice and rock and dust being warmed by the sun and ejecting its alien contents out into space to form the atmosphere of gas and material around the comet and its tail. The great thing about this is that because the material is being released by the comet, we can now try to find out what it is made of. So here's a picture. Actually, I do not think anybody has seen this yet, but as other astronomers have got similar data. This shows the amount of light coming from the comet as we go through the spectrum of light, the spectrum of color. So here again is blue through to green and red, optical light, and then we go into the infrared. And we can see from the comet areas where more light is being reflected. And each of those parts of the spectrum of the comet is a fingerprint of a type of gas. So here we have carbon molecules being ejected by this interstellar visitor for us to see. Here we have the gas cyanogen. Here we have the gas NH2, which comes from ammonia. And here we have a line due to oxygen that comes from water. So this shows that this visitor from another star contains water ice, just as comets in our own solar system contain water ice. And in fact, last month, Comet Borisov was expelling 30 liters of water every second into our solar system. So we have alien water now present in our solar system. And perhaps the most amazing thing about this, however, is that this looks just like a comet that belongs to our solar system. We can see no difference now. So out there, somewhere in the galaxy, there is a solar system that formed comets just like our solar system. And if we ever travel among the stars as a species, then we can look for places that perhaps seem just like home. And I think that is one of the most amazing things we have discovered about our alien visitors just in the past month. This is a very new result. Now, in the future, of course, we have found 2. We would like to find more. And we are building a new telescope that will help us do that. This is down in Chile, in South America. It used to be called the Large Synoptic Survey Telescope. It has now been named after a very famous female astronomer, the Vera C. Rubin Observatory. It will be finished and on sky in 3 years' time. And one thing we expect it to do is that it will find one more interstellar visitor every year. It is so powerful in scanning the sky. It can go to very faint brightness and it's very efficient. So we should find more of these visitors in the years to come. But you might wonder, are there more visitors to find? It took 400 years, we found one, then we found another one. Have we run out? Well, the fact that we found one object in our solar system allows us to calculate how many there must be that we cannot see because they are too faint or our telescopes have missed them. So here was Oumuamua, we found Borisov, and that tells us that right now, in our planetary system, but just not visible to us, there's roughly 10,000 visitors at any time from other stars. In the coming years, we will find them, we will study them, and we will learn more about planetary systems around other stars. But for now, I leave you with our 2 visitors that we have discovered, Oumuamua and Borisov. In the future, we will find more, and you will learn about it as quickly as I do. Thank you very much.